From this lecture, we will start a new chapter, that is field effect transistors, and in this lecture, I will give a small introduction about the field effect transistors. I will give a small introduction about the field effect transistors. We will try to understand what are FETs and also compare them with BJTs. We will compare FETs with bipolar junction transistors. So this is what we will do in this lecture. Now we will move to the first point, and in this point we will talk about terminals. We already know BJT is a 3-terminal device. BJT is a 3-terminal device, and like BJT, FET is also a 3-terminal device. FET is also a 3-terminal device. In this figure, you can see the first box is representing the BJT and the second box is representing the FET. And in case of BJT, we have 3 terminals. This terminal is the base terminal, this terminal is the collector terminal, and this terminal is the emitter terminal. The current IB is the input current, and the current IC is the output current in case of BJT. And in case of FET, this terminal here is the gate terminal, this terminal is the drain terminal, this terminal here is the source terminal, and the potential difference between these two terminals is equal to VGS, V subscript GS. This is the potential difference between the gate terminal and the source terminal, and the current in this branch, that is the output current, is equal to I subscript D. So BJT and FET both are 3-terminal devices. Now we will talk about applications. To a larger extent, the application of FET is same as application of BJT. The application of FET is nearly same as application of BJT. So we are done with the first point. Now we will move to the second point, and in this point we will talk about what type of device is FET. BJT is current control device. You can see here the output current is IC, and IC is equal to beta times IB, where IB is the input current. So the output current is dependent on the input current. So we say BJT is a current controlled device. On the other hand, the current ID is dependent on the voltage VGS. So FET is a voltage controlled device, and this is the main difference between BJT and FET. BJT is a current control device and FET is a voltage control device. IC is a function of current IB. Current IC is the function of input current IB. On the other hand, in case of FET, current ID is the function of voltage VGS. And you can see in both the cases, the output currents are the functions of input parameters. So we can say that the output currents in both the cases are controlled by parameters of input circuit. VGS is the input voltage in case of FET, and IB is the input current in case of BJT. So we are done with the second point, which is very important point, because this is the main difference between BJT and FET. Let's discuss the third point. If you remember the first presentation on BJT, then I told you BJT is a bipolar device. BJT is a bipolar device, and this word bipolar is reflected in the name BJT. B stands for bipolar. On the other hand, the field effect transistor is unipolar. This means FET depends solely on either electrons or holes. So FET is a unipolar device because it depends either on electrons or on holes. So this is all for the third point. Now we will move to the fourth point. And in case of FET, we have N-channel FET and P-channel FET, P-channel FET, like NPN transistor and PNP transistor. When the FET is dependent on electrons only, then we call the FET N-channel FET, and when FET depends only on holes, we call that FET P-channel FET. FET can be used for amplification as well as switching. The fourth point is FET can be used for amplification and also for switching. Like BJT, we can use FET for amplification and for switching. Let's move to the fifth point, and the fifth point is related to the hierarchy we are going to follow in this chapter. The field effect transistors can be broadly classified into two types. The first one is JFET, the junction field effect transistor, and the second one is MOSFET, metal oxide semiconductor field effect transistor. In this chapter we have to focus on these two field effect transistors. We can further classify JFET into two types. The first one is N-channel JFET and the second one is P-channel JFET. MOSFET we can classify into two types. The first one is D-MOSFET, and the second one is E-MOSFET. And again we can classify D-MOSFET into two types, N-channel, P-channel. E-MOSFET we can classify into two types, N-channel and P-channel. So this is all about the hierarchy we are going to follow in this chapter. Now let's talk about the history of field effect transistors. This is the sixth point, the history of field effect transistors. The field effect transistor was first patented by Julius Edgar Lilienfeld. Julius Edgar Lilienfeld in 1926, and by Oscar Hale in 1934. And these patents were not for the actual FET but for the concepts and FET-like devices. In 1947, William Shockley and his team tried to make a FET but failed. While they were trying to diagnose the reasons for failures, they discovered the first transistor or point contact transistor. And after 1 decade, the first JFET was made. And MOSFET, which is better than JFET, was invented by D. Kong in 1959. So this was the history of field effect transistors. Now we will move to the next point, and in this point we will try to understand meaning of field effect in the name field effect transistor. In case of field effect transistors, an electric field is developed by the charges present. An electric field is developed by the charges present, and this electric field controls the conduction path of the output circuit. This electric field controls the conduction path of the output circuit. So there is an effect due to electric field, and because of this reason we call the device field effect transistor. Now let's move to the next point, and in this point we will talk about input impedance. Field effect transistors have high input impedance as compared to BJTs. In the next point we will talk about temperature stability, FETs are more temperature stable. FETs are more temperature stable as compared to BJTs. In the next point, we will talk about area occupied or the size of FETs. Field effect transistors are smaller than bipolar junction transistors. The last point is related to sensitivity. BJTs are more sensitive to the applied signal as compared to the FETs. So this is all for this lecture. If you have any doubt, you may ask in the comment section. In the next presentation, we will discuss the construction and characteristics of JFETs, junction field effect transistors. So see you in the next presentation.